Hello, everybody, and welcome back to our discussion in Fundamentals of Surveying. We are still talking about traversing and traverse computation. For this video, I am going to talk about one of the methods. This is our fourth method, and we call it the azimuth traverse. So you may have already know that an azimuth is an angle that is measured clockwise either from the north or south end of a selected reference meridian to the line. When we say reference meridian, this is equivalent to your y-axis in the Cartesian coordinate system. Okay, ito yung vertical axis natin. So an azimuth is either measured from the positive, we call it the north, or from the negative, we call it the south. Okay, that's what we call it in surveying, the reference meridian. So in a closed azimuth traverse, the angular error is determined by again setting up on the starting point and noting the difference between initial and final azimuth readings taken along the first line of the traverse. You can see in the figure drawn in the slide the azimuth readings of all the different stations. Okay, so although I'm sorry, the stations are all D, but that's an error. Okay, I'm sorry about that. But what I want you to note about the figure is the angle is measured from the north. Okay, the angle is measured from the north. Okay, to illustrate the azimuth traverse, let us do some calculations here. So given in the accompanying tabulation are the observed data for a closed traverse. Determine the bearing and azimuth from north of all traverse lines and the angle to the right at each station. So bearing, you already know what bearing is. So we are going to get or solve for the bearing of all these lines. So we have 5 lines, and then the azimuth from the north is also unknown. What is given to us is the azimuth from the south. Okay, I'm sorry. This one, the azimuth from the south. So the problem is asking us to solve for the azimuth naman from the north. Okay, and then finally we are going to solve for the angles to the right at each station. Okay, so we have, if the station occupied is A, we have observed E and B. Okay, from A to B, the distance is 210.10 meters, and these are the azimuth. A to E is 90 degrees 28, and A to B is 170.30, as you can see in the figure here. Okay, so all data from the figure is also depicted on the table here. Okay, take note of the given data as we're going to go here every now and then to solve for the unknowns. Okay, so let us go and start solving for the azimuth first. Okay, the azimuth and the bearing. Okay, so let us start by isolating station A. I've already did the isolation here for you. The first figure is for station A. Okay, so station A, the two lines are AB, traverse lines AB and AE. But at station A, we are concerned with the azimuth and bearing of line AB. Okay, that is why we have alpha AB. The one in red is alpha AB. This is actually the needed angle for the bearing. Okay, alpha AB. And the green one, ito, from the north measured clockwise until the line is the azimuth from the north. Okay, as it's like it's almost a full circle, as you can see. Okay, because the angle is measured from the north. Okay, so given this figure, let us solve for first the bearing. Okay, alpha AB. Okay, we know that this whole thing, from the south until the end of the line is 170.30. And we know that the full line, the full straight line is 180 degrees. So basically, to solve for this small angle alpha AB, we just subtract this angle 170 degrees 30 minutes from 180 degrees. Okay, so we have alpha AB is equal to 180 degrees, and then subtract 170 degrees 30 minutes. Okay, so we have alpha AB equal to 9 degrees 30 minutes. Therefore, the bearing is, okay, we can just write here the bearing is, since we are from north going west, so we have north 9 degrees 30 minutes west. Okay, so that's bearing of AB. Okay, that's the bearing of AB. Now we are how to solve for the azimuth. Okay, as you can see, our designation for azimuth is theta. Okay, so theta AB on the other hand is just the difference between 100, or we can add the 170 degrees 30 minutes from 180. Okay, so we just add 180 and this one. Okay, so we just add that. Theta AB is equal to 180 degrees. That's full half circle, and we just need to add this azimuth from the south. Okay, that's 170 degrees 30 minutes, and we come up with 350 degrees 30 minutes. Okay, that's our bearing and azimuth for AB. Now we go to station B to solve for the azimuth and bearing of line BC. Okay, this is our figure. We have here point B, line BC, and line BA. We are given the azimuth of line BC to be 123 degrees 05 minutes. Okay, from the south going to the line, and we also have the azimuth of A. Okay, from the south we have 350 degrees 30 minutes over there. Okay, we are concerned with the bearing of BC and azimuth of BC. Okay, the bearing of BC, we need to solve for alpha BC, the one in red right here. So that's basically, okay, using this azimuth, this is 180 degrees, using the same principle actually from the first one. So we have alpha BC is equal to the straight line is 180, so that's 180 degrees minus the azimuth, it's 123 degrees 5 minutes. Okay, so we have alpha BC equal to 56.55. Okay, so 56 degrees 55 minutes. Okay, and for theta BC, our theta BC is this one. Okay, so basically that's 180 degrees plus the azimuth, the same principle. So 180 degrees plus 123 degrees 5 minutes. So theta BC is 303 degrees 5 minutes, or 05 or 5 minutes. Okay, we did not write the bearing of BC. So the bearing of BC, as you can see here, is from the north going to the west, so that's north 56 degrees 55 minutes west. Okay, so next let us go to point C. Okay, this is point C. We're concerned actually with line CD. The azimuth of CD from the south is given here. So basically the same principle applies. The bearing A alpha CD, this one, is actually equal to the given azimuth from the south. Okay, so alpha CD, We don't need to calculate, we just copy 56 degrees 13 minutes. Okay, so this is from the south going to the west, therefore the bearing is south 56 degrees 13 minutes going west. Okay, and for theta CD, okay, we just add 180 to the given azimuth, so that's 180 degrees plus 56 degrees 13 minutes, and that is equal to 180 plus 56 13 is 236 13. Okay, so that's 236 degrees 13 minutes. Let's go to point D or station D, and we are going to solve for the bearing and azimuth of line DE. Line DE is here, so we have alpha DE, the small angle right here, and this azimuth theta DE. So alpha DE is equal to, okay, as you can see, the given azimuth here is 357.58. It's almost a full circle here. So the given angle, we know that the full circle is 360 degrees, right? So to solve for this very small angle right here, we just subtract this given azimuth, 357 degrees 58 minutes from 360 degrees. So basically, alpha DE is 360 degrees minus 357 degrees 58 minutes. Okay, so alpha DE is equal to 2 degrees 02 minutes. Okay, so as you can see, this is from south going east, so the bearing is south 2 degrees 02 minutes east. And for the azimuth, alpha DE, or I mean theta DE, is equal to, okay, the given azimuth is 357.58. We're only concerned for this one, so we need to subtract the half circle 180. Okay, so that's 357 degrees 58 minutes minus the half circle 180 degrees. Okay, so that's equal to 177 degrees 58 minutes. Alright, that's the azimuth from north of line DE. And finally, let us go to the last station, station E. This is station E. Right here, we have line ED and EA, but we are concerned with the bearing and azimuth of EA. Okay, so alpha EA is this one, of course, from south going east, and theta EA is this one from the north going to the line. So alpha EA, okay, so alpha EA, given the azimuth of 270.28, we just subtract that from 360 degrees. Okay, so 360 degrees minus 270 degrees 28 minutes. So that's equal to 89 degrees 32 minutes. Therefore, the bearing of EA is south going east, so south 89 degrees 32 minutes east. And finally, for theta EA, this is the azimuth of EA from the north. This one is, so we just need to subtract 180 from 270.28. Okay, so that's 270 degrees 28 minutes minus the half circle of 180 degrees. Okay, so theta EA is 90 degrees 28 minutes. Okay, we have already solved for the bearing and azimuth of all the given traverse lines. Okay, but the problem also asks us to solve for the angles to the right of each station. Okay, so basically the angles to the right, since if we go back to our figure here, our traverse is counterclockwise, right? So our angles to the right are basically the interior angles. Okay, as you can see, if we are at point A, the angle to the right is this one. Okay, if we are at B, the angle to the right is this one. Okay, so basically, if the traverse is going in a counterclockwise manner, the interior angle is equal to the angle to the right. Okay, so basically what we are solving here, the angle to the right are the interior angle. So let us start solving for the angle to the right at point or at station A. So we are concerned with phi sub A, the one in blue. So we are given these two azimuths, the azimuth of EA and the azimuth of AB. So basically we just subtract these two azimuths together and we come up with the interior angle phi sub A. Okay, so phi sub A is equal to 170 degrees 30 minutes minus 90 degrees 28 minutes. So phi sub A is 80 degrees 02 minutes. Okay, that's the angle to the right at station A. Next, for station B, so basically for this one, this is the azimuth of line AB, this is the azimuth of BC, right? So we just need to subtract 360 degrees and 350, so we come up with this small angle here, and whatever the difference, we add to 123 degrees 5 minutes there. Okay, so that's phi sub B. Phi sub B is equal to subtract 360 degrees minus the 350 degrees 30 minutes. Okay, that's the small angle right here. And then we need to add 123 degrees 5 minutes. Okay, so alpha B or phi sub B is equal to 132 degrees 35 minutes. Okay, for station C, we have here, okay, using the same principle from the station B, so we just need to subtract 360 and 305. We come up with this angle, and then we add 5613. Okay, so phi sub C is 360 degrees minus 303 degrees 05 minutes, and then we add 56 degrees 13 minutes. Okay, so phi sub C is equal to 113 degrees 08 minutes. And then for station D, this is 357 degrees 58 minutes right there. Okay, and then if we subtract 236.13, we come up with phi sub D. Okay, so phi sub D is equal to 357 degrees 58 minutes minus 236 degrees 13 minutes. So we come up with phi sub D, a value of 121 degrees 45 minutes. And finally, for station E, phi sub E is just the difference also of the two azimuths. Okay, so phi sub E is equal to 270 degrees 28 minutes minus 177 degrees 58 minutes, and this is equal to 92 degrees 30 minutes. Okay, so that's the angle to the right of all the different stations, the 5 stations. So basically we have computed for the interior angles, right? So to check if your answer is correct, You can add all the 5 interior angles, the 5 angle to the right angles, and should be equal to n minus 2 times 180 degrees. So we have n is equal to 5 in this case. So n is equal to 5. We have the interior angle should be equal to 540 degrees, and it should check out. Okay, so that's it for the azimuth traverse. For our next video, we are going to talk about traverse computations. Okay, so see you in the next video.